To simulate the effect of small-scale relief or visible deviations in the surface of a material, use a bump map. Here in the perspective view, I've dollied in very, very close to the top of my ham radio so that I can see that bump map very clearly. Let's do a rendering with no bump map. With focus on that perspective view, go to the menus and choose Arnold, Arnold Render View, and once again initiate an interactive production rendering. Once that's finished, let's store it as a snapshot and also hold the scene updates so that the Arnold Render View will not update every time we click on something in Max. Now let's open up the Slate Material Editor once again. And we've already got the plastic black material assigned. We want to create a bump map. Most materials in 3ds Max have an input labeled bump, but the Arnold standard surface does not. It has a normal input. We can see that down here. We can zoom in a little bit with Control-Alt and middle mouse so you can see that a little bit more clearly. The fact that the Arnold standard surface does not have a bump input is actually a good thing because it gives us much greater flexibility in building bump maps. The legacy 3ds Max bump channel does not support compositing. So for example, we can't combine two maps to create a bump. But the Arnold standard surface normal input has no such limitation. The normal input refers to the so-called shading normal, which is the direction of the surface at any given pixel. We can use a map to deviate the shading normal to simulate relief. One method to do that is a so-called normal map, which uses the 3 RGB color primaries to deviate the shading normal in the 3 XYZ directions of 3D space. But a much simpler method is a bump map, which merely applies the brightness or luminance of a texture. The bump map deviates the shading normal in the direction of the surface normal, which sticks out perpendicularly at right angles to each polygon. The bump map varies the apparent height of the surface, giving the effect of surface relief. Now, a bump map can come from a 2D source texture, such as an image file on disk. It can also come from a 3D procedural texture, which is a pattern generated by an algorithm. We'll use an Arnold noise map to create a bump effect on this black plastic material. And to do that, we'll need an Arnold Bump 3D node. I'll pan around in the Slate Material Editor view with the middle mouse button. And we can create nodes connected to these inputs by simply clicking and dragging on those inputs. So we can go down to Normal, click on that input and hold the mouse down and drag out, and you'll get a red wire. Release the mouse, and you get a little pop-up window from which you can choose the node you wish to connect. Let's choose Arnold, Bump 3D. That's created and connected. It's also selected. Let's rename it here in the parameters. We'll call it Plastic Bump Map. The bump node itself will not actually create a pattern. We'll need to supply something to this bump map input. So once again, we can drag out from that input. I'll pan over with middle mouse, click and drag on that bump map input, and release. This time choose Arnold, Texture, Noise. And that's created and connected. Once again, we can select it and rename it. We'll call this one Plastic Bump Noise. Now, having made all those connections, we can restore our scene updates up here. So let's turn that back on in the Arnold Render View. And we don't see much here. There is actually a bump effect, but the issue is that the pattern is scaled so large that we can't really see much in our rendering here. So in the noise parameters, we can change the scale. Increasing the scale value actually reduces the size of the pattern. Let's bring the scale value in X up to 10. Press Tab, type in 10 for Y. Press Tab and type in 10 for Z. And now we can see we've got some kind of strange bump effect there. If we change the scale of the bump map, we'll probably also need to change the scale of the bump height. And that's done in the Bump 3D node. So let's go over there. Select Bump 3D. And the bump height parameter value is defaulted to 1. Let's bring that down to 0.1. And now we can see that we're not getting that strange effect. All right, now we can kind of see how that bump is working. It'll actually be even easier for us to see this if we just temporarily connect that noise to the base color of the material. I'll zoom back out again with Control-Alt middle mouse button and just temporarily disconnect this normal input and temporarily connect the noise output to the base color of that standard surface. And now we can see the noise effect as a grayscale rather than a bump. Let's go into those noise parameters and change those. Select that noise map, and we've got octaves. That's the number of repeats to a fractal noise pattern. With a value of 1, it's just got one layer of noise. I'll increase that to a value of 2, and now we see 2 layers of noise. And if we want faster updates, by the way, we can just update a portion or region of the screen. Up here we can enable region and then drag a window, and that's going to update much faster. We can also move that region around and resize it at will. Back in our noise parameters, we see lacunarity. That's the size of each iteration or octave relative to the one before it. It's a ratio of the wavelength or frequency of each noise pattern. And higher values are going to make it more noisy and chaotic. I'll reduce that a little bit to a value of 1.7. Then we have amplitude, which is the strength of each noise pattern relative to the one before it. I'm going to increase that. Let's bring that up to a value of 1.7 as well. And now we see we're getting a stronger effect. There's a handy parameter, distortion, which actually deviates the existing noise. Let's increase the distortion amount. We'll set that to a value of 2. And it's really made a chaotic pattern there. We can exit out of region render, and we can see that's what our noise map looks like so far. We want that to be a much smaller pattern. So let's increase the scale values in X, Y, and Z. Set those all to 30. Now we've got a very small pattern there. And that's about the right size for our bump map. So we can reconnect the bump map. Let's disconnect this base color. Reconnect the bump 3D to the normal input. And we have a very extreme bump map here. And that's because our bump 3D bump height is too high. Again, since we changed the scale of the pattern, that means we're also going to need to change the scale of the bump height. So we'll go back to that bump 3D node and bring the bump height down this time to 0.002, a very low value, but it gives us exactly the result that we wanted, which is that bump effect here. Once that's finished, once again we can make a snapshot and disable scene updates and compare the two renderings. Here's the material with no bump map, and here's the material with the bump map applied. We've enhanced the realism of the material by applying a relief effect.